Okay, guys.
Break down those puzzles.
Break down those puzzles. Sorry, it's not so much a game day. So can you guys find the related rates worksheet again? So heads up. The test next week is on Delta Math. I'm sorry, Texas. She looks so panicked. You will have paper, like white plain paper. You will write problem 1 and any kind of work that you would like graded in case you get your question wrong and you would like some partial credit for feedback on your work. But it's on Delta Math, and I know you guys don't like that. So there is a review that's on Delta Math for you, for one, to get used to the interface and not be scared of it, Tessie. It's okay. It's okay. It will be fine.
I just have a question.
Yeah.
Is that a dot after me? Like, is there
No,
rates?
that's didn't get erased from before. So there's a homework on Delta Math tonight that is to practice optimization problems as presented through Delta Math, so you can see what they're like. And to remind you that linearization was a thing. We only did it one day. You might need some review on it. So that's tonight's homework, due Monday. And then Monday morning, I have a review that's opened on Delta Math to be like, here's the kinds of chapter 4 test questions that Delta Math can ask you. So that, really it's basically, here's the test, big, with feedback, with videos, with like all the work spelled out for you to get used to. And then roll the dice Wednesday. Here is it slim and trim as your test.
So are related rates going to be on the test?
Yeah.
There's Delta Math on that, we just have to.
Yeah.
Okay.
Okay, so I would like you guys to take this sheet out again, and if you don't have the picture drawn from last class, try drawing it now, like read the words, see what you can get out of that, and I need to go pick up a worksheet that I just printed for you because it's fun.
Another word.
It doesn't make you cry, you're not crying.
Yeah, when I look at these problems.
Oh yeah, no, yeah.
Can we
Should have hit that guest speaker last period.
getting us to review?
Two guest speakers.
Seminar.
Except for all podcasts. But
Yeah, we have one once per week.
You need to cut down about
Yeah.
notes.
I
You
guess
need to
Shot.
crazy amount of notes.
Shot. I did 10 out of 10.
Okay. What'd you do on the last?
On the last
I think that's
quiz?
graded, yeah.
10 out of 10.
Yesterday or
What?
2 days ago,
How?
On
I
the
got 5 out of 10 on the last
homework
roll quiz.
2 or 3.
All right,
You know what? I was.
hey, guys, can you put your phones away? Like 6 of you have them out.
Pay attention to review days. That's what I did.
All right, David, how do we draw this picture?
It's kind of like an X and Y graph.
So the plus sign, all right, yeah?
Yep. And then you have the cop car at the top.
Okay.
And then you have the person in like the other car to the right. And then the cop car to like the middle is, I think it was 0.6. And then the center to the other thing is 0.8, I think.
Okay, the words are right here, so let's see. Cop car is approaching a right-angled intersection from the north, so it's coming this way. And yesterday we talked about, is that rate of change positive or negative? What is negative? Negative because it's going down. So the rate of change of y is going down. Doesn't tell us how fast yet. The cruiser is 0.6 miles from the intersection. The bad guy car is 0.8 miles east of the intersection. That's why David said it's over there. And the cruiser is moving at 60 miles an hour, so that's a negative. And I want to know how fast the bad guy car is getting away. And David, what was this one?
Determine the rate, like, it's just determining the distance between the police car. Wait, were you?
So I want to know, what is this piece of information in my diagram? It says
It's a line between the bad guy car and the police.
like a direct straight line, so a
Yeah.
diagonal.
Yeah.
Okay, so this line, what do I know about it? Carson, what letter should we call this distance?
Z.
Z. So the change in Z over time, all of these are rates in time. How is this changing over time? That is 20. Is it positive or negative?
Positive.
Positive. It's increasing. I think that, yeah, increasing. They said positive. And well, I think you said yesterday, how do we find Z?
I definitely did not see that.
That was Asher.
Asher. How do we find Z?
Oh, you do that with Pythagorean?
He moved seats up. Okay, Pythagorean theorem, because at this snapshot in time, this distance was 0.6, that distance was 0.8. 0.6 squared plus 0.8 squared equals Z squared. By the way, that's 1. Okay, so this is related rates. All three parts are moving. What a pain. So I need to come up with an equation that ties all three of these variables together. Carson, put the phone away. What is an equation that sets all three? Mael? What equation ties these three lengths of sides together?
So d dy.
Not derivatives yet.
Well, didn't you just give it to us?
Maybe, Ray, what do you?
Law of cosines.
Oh my goodness, ouch. No, not law of cosines.
I was thinking you got like a bunch of.
Mael?
Wait, is it y squared plus x and y?
Yeah.
Equals.
Okay,
Okay.
so all of those static lengths together, this will be true. But well, it's moving. Everything's moving over time. So what is the derivative of this whole thing, each of them with respect to time?
Well, we already found two of.
So you know all we got all this information from the problem, but regardless of what we were told, what is the derivative of this equation with respect to time?
X times dx over dt.
Yep.
Plus
Now-
2y times dy over dt.
Yep.
Equals 2z over dt.
Yeah, okay. So every stupid little thing is changing over time. And in these problems, it's still single variable calculus. I need to tell you a crap ton of information to be able to solve this.
We got a ton of stuff now.
We do. And just because I don't like big numbers and 2 is big, can I divide everybody by 2? Is that okay?
Sure.
Thanks, Will.
Gotcha.
Do I know x? Do I know what is x? 0.8. Do I know dx dt? Andy's saying no. That's the thing I'm looking for. So no, I don't know it. All right, so I'll just write that down. Do I know y?
Yeah.
What is it?
0.6.
0.6. Do I know dy dt? Negative 60. Do I know z?
Yeah, it's 1, right?
It's 1. They didn't give it to us, but by Pythagorean theorem, we could calculate it. So you got to think about it. They didn't give you that one, but looking at the triangle, I could have figured it out. And seeing how some of you were laying out your work, I didn't lay this out well. Mine is confusing. I would normally have everything written on the side clearly so I can see this is a right triangle by a right triangle, I can figure out all this information, but y is, x is, z is, and then changes. But whatever organization works for you, go for it. So z you said was 1. Do I know dz dt?
20.
20. Okay, cool. So all numbers and one variable. So finish. This is 8/10 dx dt minus 36 equals 20. And there is a reason that I've been writing it as the fractions, because I can do this without a calculator. What's 56 divided by 8? 7. So the Betty Bear car is going 70 miles per hour.
Oh, yeah.
Indy, question? Mael, can you see?
Oh, did you just finish it?
You multiply by 10/8.
So yeah, to get just dx dt, multiply by 10 over 8 and I get 70 miles per hour. Abby, you look sad.
No.
Sorry. She's like,
I'm sad.
It's-
Problems.
it's Friday.
It's so hard to carry.
I know.
Puzzles going.
I'm sorry. No
It's okay.
puzzles. I want Wednesday to not be miserable. And speaking of
How is
miserable,
Oh, hell.
this one's the hard one.
Oh,
So shush.
I got you.
Draw. What's a conical tank? It's an ice cream cone.
You introduced this problem by saying, speaking of miserable.
Okay, my bad. You're right. I mean, happiness and joy.
Someone should just get it.
We have an ice cream cone.
Why don't you just say,
I do enjoy the.
I guess to the context of the problem, why can't you just say like ice cream runs into the ice cream cone?
You put it out there, Miss
Let's draw
Pascal.
one for you.
What does it even look like?
It's like that. It's like a silo.
Yeah, it looks like a silo.
Thank you. Oh, sure.
So, reading the problem, conical tank with a point down. It looks like an ice cream cone.
Say corn, I dare
Corn. Next time it's a cube, people.
Yes.
All right, but really, we have this cone, point down.
Wait, we have
Water runs in, so it's running in. The volume is changing at 9 cubic feet per minute, and the tank stands point down. The height is 10. The base is 5. How fast is the water level rising when the tank is 6 feet deep? All right. And Mael, I promised when we do volume questions, I'll give you the volume formulas. I forgot to put it there. There it is. Cool. Thank you, Andy. Francis, in the cone, we talked about this yesterday. As the water level, the height of the water level changes, does the radius of the water change also in a cone? Yes. So Indy was the one to do this yesterday. She did product rule for us because they were each changing. I don't want to do that with this one because similar triangles, we did one of these problems with the related rates. Sorry, optimization. I was like, wait, on related rates. Woo.
Mine's on corn, I got you.
I got you. The radius to height ratio, what is it? 1 to 2. So if we reduce this, whatever the height is, that's 2 radiuses. Did I do that right?
Yeah.
Okay. So what do you think, Ryan, any suggestion on how I can make this not be so 3 letters?
Put 2R for H.
Great idea. Volume equals pi and a 3 and an r squared, and instead of h, that 2r. So far, I still have not done calculus. Here we go.
Wait, why is only the
Pi.
pi over the
Yeah.
Doesn't matter. Like,
Oh, because when you multiply, yeah.
Like-
Gotcha, yeah.
is that true?
That
Like,
makes sense.
A over 2 times B times C. The 2 underneath is dividing everybody up top, and I can count. But now I need to do the derivative with respect to time. Okay, Kyle?
dv over dt equals 3 times 2 pi over 3 r squared. These cancel with 3.
I'm missing something critical.
Oh, is it?
The RDT. So the volume is changing this way as the radius is changing that way. Okay,
We have yours?
okay. Do I have dV dt?
Oh, okay.
dV dt was 9. Okay, cool. 2 pi r squared. Do I know r?
5, right?
How do we do the derivative of the 2 pi over 3?
3.
This is just a
Oh,
number,
okay, I got it.
right? Pi it looks like a variable, but it's a symbol. It's a symbol for 3 point blah blah blah. Carson, this is effectively
I would do
What's-
implicit differentiation.
Huh?
all right, Carson. If I said this, what's the derivative? Multiply by the power, lower the power, and then do the derivative of the thing inside, right?
Yeah.
That's all,
Oh, okay.
That we did.
I got you.
Mayo?
What is the derivative of the volume?
Okay.
When you are multiplying the
So pink to pink or pink to green?
pink to green,
Okay. Mikhail said
I'm getting something different.
multiply by the power,
Right.
and then as Carson just pointed out, he was like, whoa, what's with that? This is just a constant, right? So that constant stays there. And then we lower the power. And then multiply by the derivative of r with respect to t, which is just dr dt. Yeah, okay. I don't know what the radius is, but it said when the height of the water is 6 feet deep. So if the height of the water is 6 feet deep, what's the radius? 3, because we know this relationship because of similar triangles. So pi r squared dr dt, divide by 9, those guys go away, divide by 2 pi, and I get the change in the radius.
It is 2 pi.
But how do you?
Okay, hold on.
Oh,
Yes.
it tells us. Oh, sorry.
I answered the wrong question. So,
Sorry.
and okay, but real quick to finish this though, and this was still the right way to go.
Yeah.
This asked for what is the change in the water level, not the radius. So the change in the height. Looking at all, there's now a lot of work on here. Simon, do I have anything that relates the radius to the height? You mean this thing that says the? Okay. Rasheen, what is the derivative of this little equation with respect to time? Okay, so Walter, I solved for the wrong thing. I got dr dt.
Yeah.
I swapped out the h right away because that was convenient.
So just
And
multiply that by the bad boy by 2.
Multiply that bad boy by 2
Yeah.
because dh dt is 2 times that thing we got down here.
So it's just pi.
So 1 over pi, thank you. dh dt is 1 over pi. What are the units? Feet per minute. And for those of you who are like, how did, well, volume was a cube to now I got just feet. What were the dimensions of radius here? Feet squared. Well, each of them were 1 feet. So feet squared, so, yeah? Oh, God. Okay, so related rates, there are 4 or 5 really hard questions in the textbook that I printed for you, and the printer is not printing. But do the delta math, because that's where the test is going to be, and I want you to use their kind of problems and their. Yes, Simon. Sorry?
Those are all on Canvas.
They are.